Welcome to this electrical machine 2 lecture, and in any machine there is a stator and rotor part. They will carry current, they will produce their respective field, and so there will be a stator field, there will be a rotor field, and there will be a resultant field. Now, to calculate the induced voltage in the coils, it is better to consider the resultant voltage instead of calculating the voltage induced in the stator coil because of stator field. Then you calculate the induced voltage because of rotor field, add them, you will get the correct answer. But instead of doing that, if I know where is stator field, where is rotor field, then I will add them up, get the net field or resultant field. And in fact, in terms of that, we found out in our last class, the torque is proportional to sin delta, where delta is the angle between B net and B resultant. That is also important thing. Now, in case of induction motor, how these things will look like, I will try to tell you. See, this is very interesting. For example, this is the stator structure of the induction motor, which houses a balanced 3-phase windings. These are symbolic representation of the coil sides. Similarly, on the rotor there are coil sides, and it is operating as an induction motor. Now, in case of induction motor, suppose at any time the resultant field, net field, is drawn like this. This is B net. Okay. This I will draw, and suppose this rotating field is moving in this direction with a speed n s or omega s in the anticlockwise direction. And as we know, with respect to a stationary observer, this B net will appear to move with a speed n s. Right at that instant of time, when it is positioned vertical, the question is what will be the polarity of the induced voltage in the stator conductor first. With respect to stator, B net is moving in this direction, but while applying the formula BLV to find out the polarity of the induced voltage right hand rule, what you have to do is B should be made stationary and conductor should be moving with some velocity. So, if you apply that, it will be, that is B is stationary, and then I can assume this conductor is moving in the opposite direction. So, if you apply that, this is V of the conductor respect to B net, and it will become dot and it will become cross, is not. And this is the, mind you, this is the polarity of the stator induced voltage, polarity of stator induced voltage, mind you, induced voltage. Acha, suppose induction motor is operating steadily, and with respect to a stationary observer, rotor is moving, has to move in the same direction with some rotor speed n r, and suppose n s is greater than n r, which is motoring mode, motor mode. It is motor mode, we know that. So, similarly, if you sit on the rotor conductor, B net will appear to move with the slip speed n s minus n r in this direction. Therefore, polarity of the rotor induced voltage will be also, this was stator induced voltage, this will be the rotor induced voltage polarity, which will be same. So, rotor induced voltage is same, rotor induced voltage polarity, this is dot, this is cross, that is fine. But since the rotor circuit has a resistance and reactance, the current this is the polarity of the maximum induced voltage at this instant. So, current in this conductor is not now maximum, and we have seen that in a 3-phase distributed winding, whichever phase carries maximum current, field will be along that direction, that we know I max. Therefore, how to draw the direction of the rotor field? I know this much, okay, this is at this instant, this is the maximum induced voltage, okay, and the field is moving like this. Therefore, this conductor will have maximum current when this field has moved a little bit here depending upon the power factor angle, then this fellow will be carrying maximum current. But right at this point of time, some conductor here on the right has already seen maximum induced voltage occurring in them, and when it comes here, perhaps this conductor will carry the maximum current. So, at this instant of time, rotor current, whichever conductor will carry maximum current, will be on the right, is not, because this conductor has already seen the maximum induced voltage, it is lagging power factor. So, after some time it has come here, it will be dot and it will be cross. Thank you. So, this will be the induced voltage, dot cross, mind you correctly. So, before this instant there were some conductor which has already seen B net maximum passing over it, it will be perhaps carrying maximum current. If that be the case, then the direction of the rotor field should be somewhat like this, perpendicular to this, this will be B r. And if this is B r, then I will say B r plus, because B net already I have assumed, and I will say this will be your B s red one, stator field. And if you wish that at that instant which conductors of the stator is carrying maximum current will be decided by draw a perpendicular line here, whichever conductor, and depending upon the direction it will be stator current will be maximum somewhere here, and it is very much consistent, because there is I 2, there will be I 2 dashed appearing on the stator in the opposite direction. This also indicates that. So, repeating this once again very clearly, B net is, I have started with B net, and then I have seen that rotor is moving with a speed n r, stator field n s greater than n r motor mode, and it will be like this. For example, in case of, let us see, generator mode, so that we understand, in case of synchronous induction machine, although generator mode I have not talked, what happens, induction motor will operate if the rotor speed is greater than n s, slip becomes negative, then it becomes a generator mode of operation. Mind you, please go through my notes where this has been explained in my supplementary, in the form of PDF, I have uploaded that. So, if I hope there is no confusion here. For example, in case of generator mode, what will happen? See, induction generator. You can study this after I have talked about induction generator later, but the point is, if n r is greater than n s, with slip S negative, the machine may operate as a generator. And once again I start with the stator field. Suppose this is net field, B net, it will be like this, and of course, no matter whether it is generator motor, with respect to a stationary observer, it must be moving with the synchronous speed, suppose n s in the clockwise direction. Since it is operating as a generator, rotor is also moving n r with respect to all these two speeds with respect to a stationary observer, and this time Nr is greater than Ns. So, what happens like to the previous thing, so far as the stator induced voltage polarity is concerned with respect to stator, this will remain dot and this will remain cross, and these are, mind you, the maximum voltage induced in this stator conductors. Whoever is present there, they will have this maximum voltage. Once again, by applying that rule, with respect to stator, it is moving with Ns, this will be dot, this will be cross. However, since Nr is greater than Ns, this time what will happen, that is, this field, if you are sitting on the rotor, is moving in this direction. Therefore, the polarity of the induced voltage in the rotor will change. This will become with respect to the earlier one cross, and this will become dot. Okay, this will be the polarity of the induced EMF. Now, the question is, which conductor will carry current? Now, this Nr is moving is greater than Ns. Okay, and if you are sitting on the rotor, this field will appear to move in the opposite direction. That is, in this case what happens, that the conductor, it is still inductive, it is having induced voltage. Now, a conductor on the left side, it has already seen the maximum voltage induced here. Are you getting? This is most interesting part, because this conductor is moving with Nr, Nr is greater than Ns. Therefore, this conductor, some conductor here on the left hand side must have seen the maximum induced voltage here, and therefore, when it is here, it is lagging power factor current. So, it will having maximum current in this. Therefore, the polarity of the, perhaps the current polarity will be here. Is that clear? This is the thing, this is the current maximum. If that is the current, then your BR should be like this, your BR should be perpendicular to this, somewhere here. This will be your delta, angle between BR and B net. So, electromagnetic torque will be in the opposite direction as that of the rotation in case of generator mode. Everything is nice, and your BS has to be BR plus BS. This will be your BS, and a line perpendicular to this will give you the, this is the arrow of the stator field. So, this may be cross, this side, this may be dot, and also it is consistent, opposite currents will come, I 2 dash, everything will be valid, and this will be BS, and it will go like this. So, in case of both motoring and generating mode, it is there. Similarly, the rotor, and mind you, this is delta, and we have already seen that the electromagnetic BR towards B net is the direction of the torque. In case of motoring mode, you see this is delta, this will be delta, and the torque will be in this direction along the direction of rotation. Everything is now consistent. So, both motor mode and generator mode, these are the direction of the fields. In case of synchronous motor also it can be drawn. I am not now drawing it, although I have included in my note. In case of synchronous machine, it is much more simpler. So, because everything is rotating at synchronous speed. So, kindly go through the notes with this understanding. Induction motor, it is tougher. Of course, I must add one point. I have assumed the machine is running with some slip n s minus n r by n s, is not? I have, if the machine is running under no load condition, slip value is small. So, that circuit is almost resistive. Then suppose slip is very small, motor mode, slip small. Okay. Then in case of motor mode, I have already drawn. So, I will draw like this. This is dot, this is cross, stator induced voltage, your B net moving with speed n s, that is fine, it will be moving. Rotor induced voltage also will have same polarity, cross dot. But in that case, the rotor, if slip is small, magnitude of the rotor induced voltage is small, and whatever current it will cause, it will be almost in phase with the voltage. In that case, what will happen? A conductor on the right already has seen maximum voltage a little away from this, depending upon exact magnitude of the slip. Slip is small, therefore, rotor voltage may be here, induced current will be maximum here, and the strength of the rotor field will be perpendicular to this line, but this length will be very small, that is your BR, and then your BS will be like this. Got the point. Therefore, depending upon the value of the slip, this length will change, which B will remain practically constant. It is B net in case of induction motor operation, because that induced voltage induced in the rotor and supply voltage must match if you neglect that leakage impedance drop. This will be, so B net will remain practically constant as slip changes. Got the point. Therefore, henceforth, and I will just tell you one thing, that henceforth, therefore, in any machine, if there is a net field, this is the conclusion I want to draw, B net, rotor field, maybe here there rotor field BR will be there, this angle is delta, and this will be the situation, and electromagnetic torque is in this direction, direction of rotation of rotor NR also in the same direction, rotor rotation. For this is for motor mode, and for generator mode it will be BR will be here, this is B net and BR will be somewhere there. Direction of rotation of the rotor is once again this rotor rotation will be there, delta torque angle is this, but the direction of the electromagnetic torque will be this way. So, this is the thing we should be keeping in our mind, and this is true for operation of any of the machines, be it induction, be it synchronous, be it DC machine, the direction of the field can be properly drawn. And not only that, coupled with this idea that at any instant when I am drawing BS naught here, the resultant field of stator or rotor it is difficult, but they are carrying time varying current, no doubt, but at least I am sure when, for example, A phase instantaneous current is maximum. So, perpendicular to the A phase coil magnetic axis, your resultant field is lying. That is the information I have used here. When I say that Bs is here, I mean that perpendicular to this line, whatever phase exists here, they are carrying maximum current, or whatever phase belts A or B phase, if it is, they are carrying, their together effect is that one. So, I can say if this is Bs, perhaps A phase maximum is here, something like that. Therefore, a rotating magnetic field gives you the electromagnetic torque of a machine when it interacts with your rotor field. The electromagnetic torque produced can be, you can live with Bs and Br, still get electromagnetic torque, which in our earlier case I told the angle between Bs and Br is gamma. But so magnitude of Bs, magnitude of Br sin gamma is the torque. But people like to express the torque in terms of the net field. Why? Because if you want to live with Bs and Br for analyzing the machine, nothing wrong in that, but then every time to calculate the induced voltage in the stator coil, you have to calculate it separately for Bs, separately for Br depending upon their relative velocities, and then finally come up with that. So, it is better you try to, instead of individually calculating, you get the resultant field, net field. For net field, whatever is the induced voltage, in one stroke I can get, because B net is all B are sinusoidally distributed, that is what we have assumed, only fundamental component of the MMF we are considering. Therefore, they will have sinusoidal induced voltage, flux per pole will be 4 pi P B net L R, resultant flux per pole. Then use that famous formula root 2 pi f etcetera to get the induced voltage. And this B net will also decide what will be the induced voltage in the rotor. Polarity of the induced voltage when B is moving is slightly tricky, because we know this formula, when a conductor moves and there is a magnetic field, conductor is moving relative to the field, voltage is BLV, then only you are allowed to apply the right hand rule, okay, like this. B, V is thumb. So, B thumb, and this way this resultant field you can calculate. But in this case, stator conductor is fixed, B is moving like this. Therefore, what you can assume that B net is stationary, and imagine to get this dot polarity, imagine this is moving, and then apply right hand rule to get the polarity of the induced voltage. Okay. So, this topic is important. Okay. Thank you.